Hello and good morning or good evening actually. So I'm here to report about long shunt compounded DC generator and motor problems. So I'm Kyle Villanueva and I'm here to give some example problems. So for the first problem, we have a long shunt compound generator that has a terminal voltage which is 230 volts. When generator delivers 150 amps, determine the induced EMF and total power generated. Given that the shunt field diverter and armature resistances are 92 ohm, 0.015 ohm, 0.03 ohm, and 0.032 ohm respectively. So to be able for us to determine the voltage generated by armature, oh, wait, to be able for us, sorry, to determine the voltage generated by armature, we do have to determine the combined resistances of the series field resistance and diverter resistances. So since the two are in parallel, which is given as since the two are in parallel, the series field resistance and the diverter resistances, we do have this equation. So RC will be multiplied to R diverter, RD, then the RSE or the series field plus RD. So we will have 0.03, which is the RD, sorry, this is the RD one. And for the series field resistances, we have 0.15, 0.15 over. So for the RD, sorry for the mix-up, 0.03 again, and 0.015. So the answer for that will be 0.01 ohm. Yes. So after we got that 0.01 ohm, so we do have the combined resistances. So next is we will have the total resistance produced by the whole shunt compound generator. So for this, we will add the remaining resistance, which is the 0.032, the shunt field. Oh, no, the shunt field. The armature resistance. The armature resistance, which is 0.032, adding that to the previously obtained combined resistances of the series field and diverter, which is 0.01. Thus having a total resistance of 0.042 ohm. We have 0.042 ohm. Now, what about the voltage drop? So in order to determine the voltage generated by the armature, we do have to determine the voltage drop. So next is we will use this one, the total resistance, and we will have to obtain the current IA, which is the armature current. So how do we obtain that? So first, First, we will have to obtain the current on the shunt. So to obtain the current on the shunt, we will see VT or the 230 volts terminal voltage and the armature resistance, which is 92 ohm. So we will have 230 over 92 will be equal to 2.5 amps. So far, we have obtained the current in the shunt, we have obtained the total resistance. So next we will have to obtain the armature current. So how do we obtain that? So the next step is we will have to use the IL or the current that the generator delivers. So the IL has a value of 150 and the previously obtained ISH is at 2.5. So to be able to obtain the IA, we only have to add the total load and IA, total load in which the generator delivers. When it is at 30 volts. Sorry, sir. So in this case, we will have to add, we will have to add 150 plus 2.5. 2.5. So IA will be equal to 150 plus 2.5 equal to 152.5. So here we obtain the current in the armature. So with that said, we can now obtain the voltage generator by the armature. So E, the equation for that is E is equal to the terminal voltage plus the voltage drop. Oh, so we do have to obtain the voltage drop first. So voltage drop will be equal to 152, which we obtained from the armature current, 152.5 multiplied by 0.042. This was the total resistance that was obtained earlier. So once you multiply, the answer will be 6.4 volts. Now here, returning here, so voltage drop plus 6.4 volts, 430 plus 6.4 So given that, so the total power or the total voltage generated by the armature will be total voltage will be 236.4 volts. So we have the total voltage. Now, we will obtain the total power generated by the armature. So for that, we will use the obtained voltage generated, which is 230. So this is the generated and armature. With that, this is the equation for us to obtain the power generated in armature, voltage times current. So we will multiply the 236.4, which we obtained earlier, from the voltage generated by the armature, multiplied by 152.5 amps, which we obtained from the previously solved current on armature, in which we use the shunt current with the armature resistance. So we obtain that, then 2.5 amps, then 150 plus 2.5 amps, then 152.5 amps for this, and the total generated by voltage by the armature is this one, 230 plus the voltage drop. So the final answer will be 36,051 watts. So for this one, we obtain the total power generated and the induced EMF as well. So for the next one, for the next example, we do have a long shunt compound generator in which delivers a load current of 50 amps at 500 volts and has an armature series field shunt and shunt field resistances of 0.05 ohm, 0.03 ohm, and 250 ohm respectively. So we will have to calculate the generated voltage and armature current. So here we will allow 1 volt per brush for contact drop. So we have a given of 500 volts for VT. So for IL, we have 50 amps, IL current load. For RA is 0.05, which is the armature resistance. Next is the RSE, or the series field resistance, which is 0.03 ohm, and 250 ohm for the shunt field resistance. And lastly, we have a 1 volt per brush for contact drop. So the first thing that we will do is to determine the current through the shunt field winding. So for us to determine that, we do need to use ISH is equal to ISH, which is current on the shunt motor, RSH, and then we will have to use the VT 500 volts over the shunt field resistance, which is RSH. So here we will have 500 volts divided by 250 volt, 250 ohms. So for this, we will be having a 2 amp. So why do you have to obtain I shunt? Because we will use that to obtain the current in the armature. So for the current in the armature, we do have to use IL, which is the current load, then adding the previously obtained I shunt, ISH. So for that, this will be 50 plus 2 amps. And the answer will be 52 amps. So this is the final answer, or rather the answer for the armature current. Next, we have to obtain the generated voltage. So first, as we did earlier, we do need to obtain the voltage drop first. So for the voltage drop, we will use the voltage drop, voltage. Sorry for the writings, it's quite hard in using a mouse. For the voltage drop, we will use the previously obtained IA, or the current in the armature. Then we will have to multiply it to 0.05, which is the armature resistance. Then adding it with the 0.03, which is the series field resistance. So RC. Now, after that, we will have 0.05 plus 0.03. And multiplying the previously obtained 52 amps. For that, we will be having a voltage drop of 4.16 volts. Now, since we have the voltage drop, then we will be one step closer in obtaining the generated voltage. However, there is voltage drop at the brushes. So here, we will use the I shunt, ISH. ISH. Then we'll be multiplying that with the 1 volt per brush. Then we will have 2 volts. That will be voltage drop for each brush at brushes. So next, since we obtained the voltage drops required, now we can obtain the EG, or the generated voltage. So for that, we have VT. We will use the total generated voltage, or the total voltage in the compound generator, which is 500 volts here. And then plus I armature, then multiply with RA, which is the armature resistance, plus the series drop, So we always add series, all the drops. So adding the series drop will be series drop. Next, after that, we will also add the obtained brush drop, which is 2 volts. Now we have our equation to obtain the total generated voltage. So by doing this, we will add 500 plus 4.16 plus 2. So far, sorry for the inconvenience. So we have 506.16 volts. So this will be the final answer. So thank you for listening, and that's it for the long shunt compound generators.